So we're going to have some practice in verifying identities. As our first example, we're asked to verify that 2 sine A sine B is cosine A minus B minus cosine A plus B. Okay. Now, a couple tricks come in. First of all, the more complicated side is the right-hand side because that's the one with complicated angles inside the trigonometric functions. So we're going to start with the right-hand side. Now, another one of our verification tricks said to make sure that the angles matched. You can't turn an A into a B, but you can most definitely simplify these A minus B, A plus B down into just A's and B's. And we're going to do that using the sum and difference identity. So by the sum and difference identities, this first one turns into cosine A cosine B plus sine A sine B. Okay. Minus, the second one, it turns into cosine A cosine B minus sine A sine B. And you need some kind of parentheses so that this negative sign will distribute. Now we notice that the cosine A cosine B and the cosine A cosine B cancel because of the minus in the middle. And I'm left with sine A sine B minus a negative or plus sine A sine B. So there are two of them. So I can add them together, and I get my original left-hand side. Now I like to note when I'm done with a proof. One of the common ways of doing this is a little filled-in box to say, I'm done, you can stop trying to read it now. Okay. So again, we use sum and difference identities because we wanted to get rid of these complicated angles, and after that we just combined things as they looked, and the correct answer fell out. Okay. Now, our next one is to verify secant x divided by cosine x minus tangent x divided by cotangent x equals 1. Now, once again, we immediately decide we're going to work on the left-hand side because it's clearly the more complicated side. Next, we're going to use one of my favorite verification tricks, which is to turn everything into sines and cosines to make it easier to understand. Okay, so secant is 1 over cosine. Tangent is sine over cosine. And cotangent is cosine over sine. Now, this may not look any better. Excuse me, we don't actually know it's 1 yet. This may not look any better at the moment, but the reason we like this is because of another verification trick that told us to follow through on any algebra. So as soon as you see complicated fractions like this, you should immediately say, I'm going to clean up the fractions. Okay. If you remember here, instead of dividing by cosine, we can multiply by 1 over cosine. So this turns into 1 over cosine squared. Here, instead of dividing by a fraction, we can multiply by the reciprocal. So we have sine over cosine times sine over cosine, which gives us sine squared over cosine squared. Because they have the same denominator, it's fairly obvious we should add them. Now, I'm going to use another trick that tells me to use one side to guide the other. I need to end up with 1. And the only way for a fraction to equal 1 is if the top and the bottom are equal. So I need to turn either the top into cosine squared or the bottom into 1 minus sine squared. It's a little bit easier to see maybe that 1 minus sine squared via the Pythagorean theorem identity is just cosine squared. And then cosine squared over cosine squared, in fact, gives me 1. Okay. So most of this, after we turned to sines and cosines, it was following your nose, meaning we should clear the fractions, we should add the fractions, and then at the very end, we chose an identity that would make the top and the bottom be identical so that we could get the 1 on the right-hand side. We're going to do one more verification example in this video. This one is a little bit more complicated. Now, when you're choosing which side to work with, you may think the fractions are more complicated, but I'm still going to choose the right-hand side. And the reason is sine is a very simple type of trigonometric function, whereas secant and tangent themselves are complicated. So we are going to choose to work on the right-hand side. Now, there's another choice to make, and that's should you work on the inside or should you FOIL it out and get rid of the squared. And I'm going to choose to work on the inside first and deal with the square on the outside later. So, my first step, since I don't know how to do secant minus tangent, is to turn everything into sines and cosines. And then I noticed, hey, those have the same denominator, so I can add them. Okay. Now, there's not much left I can do in the inside, so now I'm going to actually do the square. I am not going to FOIL out the numerator. Excuse me, it would help if I wrote something that's actually true. I'm not going to FOIL out the numerator because I've seen things like this before. Now, we want to end up with things with only sine in them. So, I need to get rid of this cosine and turn it into a sine. And our favorite way of doing that is using the Pythagorean identity. I like to write when I use an identity. This is twofold. It helps me, but it also helps the grader when they're going through so that they can try to give you more partial credit. So the Pythagorean identity turns cosine squared into 1 minus sine squared. And now we're going to use another verification trick, which is to look for factorizations. The numerator is already factored, but the denominator isn't, and it's a difference of squares. Okay? And we know how a difference of squares factors. The first thing square rooted plus the second thing square rooted, and then the same thing only with a minus sign in it. Now the reason we like this is now we notice that I have a factor in common on top and bottom. So I'm going to cancel this 1 minus sine x with one of these, and I'm just left with 1 minus sine x over 1 plus sine x, which is what I wanted to reach in the first place.